This is question number 2. You might actually have to take some notes for this. We're going to talk about the criterion side angle side in this example, and I'm going to show you how to use this. If you were having trouble on the previous night's homework or classwork, this should help you right now. So given that A, B, and C and triangle M, L, and M are existing right here, and that angle B is equal to angle L, do me a favor, if you haven't marked on your paper that angle B is equal to angle L, go ahead and mark it up. That's right. Mark up the figure, and then determine if the triangles are similar. How are we going to determine that the triangles are similar? We're going to use the criterion. If the sides are proportional, two of the sides, and its included angle is equal, then we can prove using side angle side that the triangles are similar. Similar to congruence, but not, because this is about similarity in proportions. If so, write a similarity statement and state the criterion used to support your claim. So we know that the angle B and angle L are equal to each other. So that takes care of the A part and side angle side. Let's test if the sides are proportional. But first we have to figure out what are the corresponding sides. So A and B, which is this value here, A and B, corresponds to, use the letters that are given to you. You can assume in this case that the letters are corresponding with each other, which means A, the first letter corresponds with the first letter M, B, the second letter corresponds with the second letter L, and C corresponds with the third letter N here. You can assume that in this case, and in general, all the cases I've come by, you can assume that. So A, B, the first two letters here, corresponds to the first two letters here. And then what else do we have? We have information for BC. So BC corresponds with the second and third letters here, LN. Once we plug in the numbers that we have for this, then we can test if they are proportional. If they are proportional, then the whole triangles are similar. So A and B is 8, and then M and L is 3. B and C is 12.23, nope, 12 and 2/3, which I bet you guys love seeing, this beautiful mixed number, and 4 and 3/4. Now, this left side seems pretty straightforward to plug into a calculator. This right side, I'll give you a little tip. But just in general, right here, 4 and 3/4, 3/4 is 0.75. That one I know. 2/3 is, 1/3 is 0.3 forever, and then 2 of those is 0.6 forever. So 12.6 forever. So let's see what this ratio is. I just converted the mixed numbers into decimals. The awesome thing that you can do is convert both of these mixed numbers to improper fractions and then do some fraction division to see if it is equal to 8/3. That would be the super most awesome way to do it. So 8/3, let's clear this. 8/3 is equal to 2.6 forever. 2.66 forever. Let's see if this 12.6 and this 4.75 is also equal to 2.6 forever. 12.6 forever divided by 4.75 equals 2.6 forever. What do you think? This is different, huh? You can take a look. Yes, rounding error. Those of you that said rounding error right when I said that. Nope, I went great. 2.6 forever. So yes, the sides are similar. Let's write this. Because the sides are in proportion and the included angles are congruent, the triangle ABC is similar, or how about this symbol? Shift, this tilde key is similar to triangle ML and N by SAS. Nice, right? Okay. Summary. What are the other theorems that can be used to prove two triangles are similar? Well, angle. We've talked about this. We talked about how you don't need all three angles to be equal, because if you know two of the angles, you automatically know the third angle. So this is angle. And this is if the angles are congruent, which means the same measure. And congruent. All right, we have side, angle, side. So this means side, angle, side. It means the sides are proportional. Proportional. And then the angles are congruent. Use this example up here to hone down what side angle side is. The final one is what we've been doing since the beginning of dilations, is all sides, corresponding sides, corresponding, are proportional, which means they have the same scale factor. Is this how you spell proportional? Oh my gosh. Sorry if this is not how you spell it. I can't. Whoa. I don't. Okay. That is question number 2.